computer. Okay, I guess we're good. And today's, how do I, just a second, let me remove most of it. And I will remove the ribbon. Okay, this is better. So today's presentation is about Linux, Unix, something which I really like. I worked with Unix for probably about 25 years, more than that. And there will be several topics. I'll talk about Unix, Linux, a little bit of history, how to install Linux on laptop. Exercise which I've done recently, was amazed how easy and good the results are. Setting up Linux virtual machine on cloud, VI Vim editor, Bash shell, working on Mac OS, which is also Unix, and Linux on Microsoft Windows. Hope you'll enjoy it, and we'll start with a little bit of history. So Unix nowadays is a dominating operating system with billions of Android devices, iPhones or iPads, servers on the cloud, 100 million Mac computers. So it really the most frequently seen used operating system on the planet. And the person who started it all is Ken Thompson, an amazing guy. So he created Unix OS in 1969. Think Apollo mission to the moon. So he was working here in New Jersey, in Bell Labs, and now he is at Google, and he's one of the co-creators of Go language. So there is a lot of history, videos, his interview on YouTube. I highly recommend to learn. Amazing guy, very talented. So he wrote his operating system because he wanted to play computer games. He wrote a game, something like space travel, first in assembly language, then he wrote a B language. This piece of code here is in B language. And if you know C, you would say, no, Lev, it's C language. They're very similar. Of course, C had more functionality, and Dennis Ritchie joined, and in 71, 72, they rewrote Unix operating system and rewrote language and call it C language. So this is the beginning of Unix. Interesting, first Unix was running on a computer with only 4K of memory, really, really tiny. Then Ken Thompson returned to California, to University of California, Berkeley, his alma mater. He introduced people there to Unix, and this started the BSD, Berkeley Software Distribution, so BSD version of Unix. Later, there were two competing versions, one coming from Bell Labs from New Jersey, and another coming from Berkeley. There was a lot of legal cases. It was really a war. Another thing interesting, that Steve Jobs, when he was kicked out of Apple, he started a company to create a next station, and it is based on Unix. So it's a customized BSD distribution version of Unix. And then Linux, of course. So Linus Torvalds. So, well, first of all, thanks to Richard Stallman, who came up with the idea of open source licensing. And then Linus Torvalds created his version of Unix and called it Linux because his name is Linus. And this is nowadays the most common operating system on computers and servers, and that's what we'll be talking today. Okay, I just want to say a few more words about Linus Torvalds. He actually famous for two systems. One is Linux and another is Git, which is version control. And Git in some slang means unpleasant person. So he was joking that he always names his products after himself. So Linus Torvalds is a celebrity. He was leading Linux kernel development for tens of years. He's paid millions of dollars. Um, Again, many interviews on YouTube. Highly recommend to follow him. Very wise, very original thinking, very blunt in like, for example, I remember in one of his interviews, he was cursing Java for being absolutely terrible. And anyway, so Linux distributions. Nowadays there are hundreds, more than 600 different Linux distributions. You can search the statistics and different kinds. The most common on clouds is Ubuntu, and the most common on workstations, laptops is Linux Mint, which is also based on Ubuntu. So this is one of the, like, if you just search for different distributions like tree, ancestry of Linux systems, you'll see there's a lot. So you may have Linux installed on your desktop, on your laptop, and it is very similar to Microsoft Windows, how it feels. Really, you will feel at home after Windows. It's the same thing. And of course, Linux terminal, where you can run commands. You get the prompt and you run commands. And the program which talks to you is called shell, and there are multiple shells. Original shell, C shell, corn shell, TC shell, born again shell, Z shell, fish. Fish is a friendly interactive shell, I think. This is what I use on my Mac. I really like it. But on servers, I usually just use bash because it's standard. And there are multiple tutorials for basic commands, bash commands, which you can find and watch on YouTube and try and use. Okay, a couple more things. A VI editor. At the very beginning of Unix development, people needed some sort of editor. And VI editor was written by Bill Joy, who co-founded Sun in 1982, together with Chuck Halley, who also wrote X line editor. So X is a one-line editor, whereas VI allows you to edit multiple lines, but you have to switch between the lines. So you have two modes. In one mode, you edit the line. In another mode, you travel between the lines. So VI was very primitive, but it was from the very beginning. It's included in all the Unix distributions. And if you know VI, it's like doors into Unix world. And shortcuts, which are used in VI, also used in many other Unix systems. So if you learn VI, you start feeling like at home with Unix commands. And it's important, I think, to learn VI. Now, about shell. So there was original shell written by Stephen Bourne, and the initial release was in 1979. And then there was Bash Shell, or Born Again Shell, by Brian Fox. And you see it was released in 1989. So it was available at the time when Linus Torvalds was creating his first Linux version. And so he have chosen to use Bash, and Bash is like signature of Linux. Okay, installing Linux on laptop. So this is my recent experience. I got a Dell XPS laptop and 15-inch, pretty standard, and just used instructions on Linux Mint website. There are instructions how to download the ISO file. It's about 2.5 gigabytes. It's like an installation disk, and you burn it into a USB flash drive using software which is called Balena Etcher. So it formats the USB flash drive and installs the software on it, so it becomes a bootable flash drive. And then on this laptop, all you do, you restart it while pressing F2 to get into BIOS. You change the boot order, you put USB first in the list, and then you restart, it boots from USB, you follow prompts, and boom, 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 you have Linux. And it's really easy, and everything works. I was afraid that maybe some drivers are not working, maybe when you close the lid and then you open, it will not wake up, or like something else will happen. No, just everything works. Absolutely amazing. Very friendly, very easy to figure out. Any questions you may have, just Google, boom, immediate result. Just a pleasure. There is absolutely no reason to use Windows after you have Linux. No, that's not true. On Windows, you still have things like Adobe Photoshop, for example. There are few things which, as far as Microsoft Office, Linux comes with LibreOffice, so it can read and write Microsoft files. So, yeah, other than Adobe Photoshop or like other Adobe products, I don't know. Like for me, I would just go with Linux because frankly, I don't use Adobe. Configuring Linux virtual machine on cloud. So there will be several pages where I describe common procedure how I do that. It's absolutely the same. It's very close, whether you do it on Amazon Cloud, Azure Cloud, Google Cloud Platform, or some other cloud. So first you go, let's say you go to portal.azure.com, suppose you have an account, and you provision a virtual machine. So you search for virtual machine, click on create new, and then answer some questions. So in this particular case, I selected Linux Ubuntu server with 16 virtual CPUs, 64 gigabytes of RAM, and I added extra disk. Usually you need to do this because the operating system disk which comes with it is usually small. It's like 20 something gigabytes, very small. You cannot really work on it. Default user given to you is Azure user. And you need to go into network interface. Again, it's in the browser when you create it, and make sure that these ports are open. This is for SSH, HTTP, HTTPS. For SSH, you may open another port. Sometimes for security, people close port 22 and use some other port for extra security. Then in order to communicate with the computer, you need to have SSH keys. When you clicking in the browser, creating the computer, there will be an option. It will generate the keys for you. Or you can create it yourself and then paste it in the interface. Either way, one of the keys will end up on the server in the .ssh directory. And then you have to do some setting on your computer. So what's happening under your home directory, you should have .ssh subdirectory. And usually what I do for every computer, I create a different subdirectory where I keep the keys. To give you an idea, so this is a terminal on my computer, and I go into .ssh directory, and you see multiple subdirectories. And if I go into some subdirectory, you see public and private keys. And then you have a config file where you have different entries. So if I cat it config, so you see, for example, how it looks. And each one, you have the router, well, in this case, it's root. You have IP address, you have where the key goes. And then when you want to get into some machine, you can address it by the alias, the host alias. So here, for example, we have IP address, but we can use alias, in this case, IPC, to connect to it. Okay. Also important when you set up a SSH directory, to make sure that files and directories are owned only by you. So if they owned, if a permission are more open, then SSH will not work. So this chmod command are important. Okay, so this is, and once you did this, you can do SSH space alias of the server, and it will connect to the server in the terminal, and then you can work on the server. Okay, usually you need to remove the banner because every time you log in, it shows you a lot of stuff which you don't want to see. If you go into this directory, you will see a lot of scripts which are running when you log in. You can make most of them not executable, -X, and you make executable only one. That's what I do, reboot required, so that when there's some updates, you know that you need to reboot the computer. Okay, then you need to partition and mount this additional 2 terabyte disk or 4 terabyte disk or whatever. I just provided the links how to do it. It's too technical for this presentation. Git, yes, make sure you have latest Git. And on Ubuntu systems, what you do commands like that: apt-get update, apt-get install, in this case, install Git. And you can see the version. Okay. Next, more commands. Okay, I recommend to clone my repository on github.com/lselector setup computer. And under this directory, there are a lot of utilities, environmental setting files, dot files, which you can use. So it's good to have it locally. One of the things I always do, under this repository, there is a dot directory, and there is a lot of setting files. I copy them in home directory and rename them into dot files, like .vimrc for vim, .inputrc to modify the shortcut behavior on prompt, profile, bash profile, bash aliases, bash rc. So after you do all that, then you'll get a consistent environment when you log in into the prompt. A lot of convenient aliases will work and so on. All this is on GitHub. You can just go there and look at these files, what they're doing. One utility which I really like is fdefined. Fdefined is much better than standard Unix find. It's much faster. It's parallel under the hood. Just amazingly how fast it is. And it's very easy to install it. It's 2 commands. First, you install it using apt, sudo apt install fdefined. And what it installs, the executable is called fdefined. And I want it to be fd. So I create a link, a symbolic link to put it into this directory. Well, if it not exists, I have to create this directory, or I can put it in some other directory. But the end result is that I have fd command, and then I can just find something. Okay. Next is swap file. By default, a swap file either doesn't exist or too small, and I always make it bigger. On some computers, I make it like 64 gigabytes. So swap file is place on disk, which is used instead of memory when your process is running out of memory. On Mac computer, you don't have to worry about it because Mac expands swap dynamically, but on regular Linux, you have to create it. And here are system or commands. So what you do, you create a file. In this case, it will be data swap file. The size of the file will be 16 gigabytes. And you change permissions, you do make swipes and turn swap on, and after that you will have this swap working. There are several ways to check it, and when you reboot the computer, you want to make sure that swap will start working, and for this you need to edit this file etc fstab and add this line to this file. So this file is owned by root. So when you edit it, you have to use sudo. You have to, I think it's read-only, so you have to overwrite that as well. I recommend to make a backup copy before you edit this file. And then you do sudo reboot to reboot your machine and check that swap goes on and is working after this. Another thing is installing Python. Of course, Linux already comes with some sort of Python, but it's not the latest. It's not the one you want to use. So what I do, I install Miniconda Python and then install modules, extra modules which I want. So this is the command to get Miniconda. Well, you can just Google for Miniconda. You'll find the website with different distributions. You select the one which corresponds to the type of CPU you have. This is, I believe, for regular Intel CPU. Okay, and then after you download this script, This is actually shell script, and then you just run it like this, and it will install Miniconda, and it will ask you where you want to have it. I recommend to put it on a separate drive, which you install, this 2 terabyte drive. And then you choose to initialize and dot files, whatever. It's a part of configuration. It's set in bash rc. So if you just look at what I have described before, how you copy, it has all the settings. You check that Python, pip, and IPython all point to under this directory. And if you go to this directory, this is where we cloned my repository with setup instructions. There is a file there called Miniconda requirements. And you can edit it, you can remove modules which you don't need, and then you do pip install -r this requirements file. I like data science, so there are some modules related to data science which you most probably don't need. So I recommend to first remove stuff which you don't need from this file. Okay, then what you need to do, you need to create your IPython profile. And IPython profile lives in this directory. Under home directory, there is a .ipython subdirectory. If it doesn't exist after this installation, you create it like this, IPython profile create. Then you go in this directory, there is a default profile there, there is startup subdirectory there, and you just copy some startup files from my setup, whatever repository, into this directory. What it will do, it will, every time you start IPython, it will automatically import some functionality which will make your life easier. Again, you can just look at the code of the files which are being installed there. Also, what I recommend to do is to go under Miniconda directory and look for IPython config file, ipython_config.py. You can use fd utility to search. You will find several instances of this file. They all the same. Take one of them and copy it under this directory. And then when you open it for editing, you'll see that it mostly everything is commented out. That's fine. You just scroll all the way down and add these 2 lines at the end and save it. And then you can test IPython in terminal. Everything should work. It's very reproducible every time. I've done it so many times on so many computers. Same thing over and over again. Okay, now configuring Linux virtual machine on cloud, part 5. It was 3. It should be part 4. Come on. Okay, so what I do next is I create multiple directories where I'll keep my code and Python libraries and log files and old log files and test log files. Under, again, my setup repository, there is a miscellaneous directory where I have some maintenance scripts and so on. You can just copy it here, and they come with documentations how to use it and schedule on a regular basis, so that important files like your dot files or some other configuration files are copied on a regular basis and backed up. I usually keep about 2 months of backups, so in case something gets broken, you always have backups to restore stuff. And some other utility commands. So what you can do, you can go to this link and this setup new Linux. This is actually directory, and you will see some files there, and just you can follow instructions and documentation there. Okay, it's getting too technical. Now, VI Vim editor. As I told you, this is like the heart of Unix, and it was written by Bill Joy in 1976 as a multi-line improvement of Line Editor X, with Joy written by Chuck Halley again. And then later, a new version was created, Vim, which is VI improved. And by default, nowadays, when you get Linux, you always get Vim, of course, or maybe even Neo Vim or some other version of Vim. Okay, And here there are some short instructions how to use VI Vim. I don't want to go through them. I just want to say that, well, as I mentioned before, there is insertion mode where you type. There is a command navigation mode where you go up, down, and you can copy, paste, whatever. And there is also column mode where you can do some advanced commands. Like, for example, you can um, search and replace using regular expression, or you can read contents of one file into another, or you can run shell command, or like many other things you can do. So these are commands. So for example, if you want to write file to save it, you do column and then say write. Or if you say write quit, this is very common. Sometimes people use column X, which does writing only if the file changed. If not changed, it will not write. So, oh gosh, inserting text, insert, append, open new line after or before. This is very common. Small letter means go down, big letter means go up before. Motion, deleting text. Standard VI or Vim, they do not work with mouse. But newer versions like New Vim, it can understand mouse. You can enable this functionality. In fact, you can switch Vim into a mode where it will behave like regular text editor. So you don't need to switch between insertion and navigation modes. Although I'm old-timer, I still use Vim as if it is VI, except for visual mode. Visual mode is a very simple thing. You press V and then you start moving with your arrows, let's say, and you will see that it highlights the text. And you can select any piece of text, or you can do with Shift, you select lines, or with Control, you can select columns. And then after you select it, you can do something with it. You can delete it, copy it, substitute, and so on. Very powerful, very convenient. You can search for strings, you can replace, you can search and replace using regular expressions. Each command can have a count attached to it. So you can repeat command given a number of times, or you can also specify like go from here till the end of the file, for example, whatever. You can specify ranges, like from here to the end of the line of the file. This is the example, and substitute this pattern by this pattern and do it if several times on the line, do all of them. G means global, and so on. Anyway, file operations. Next file, you can open multiple files and then you can navigate between them. In fact, you can have tabs if you want. Okay, different commands. J, join lines, very common. So if you have several lines, let's say 2 lines, and you want to join them together, this is the command you will use. Dot means repeat the command. So for example, you commented one line and then you want to comment another line, you just go to its beginning and press dot, and it will comment this line. Or it will do much more complex operation, whatever the last edit was. So for example, you were changing one word to another, and it will repeat this change. Undo last change, very important command, undo. And undo all changes on the line, refresh the window. Okay, now we're switching gears to the bash. I really recommend, if you're not a Unix user, just go on YouTube and pick up any kind of beginner's tutorial for bash, for Unix prompt, for Unix terminal. And you will see all these common commands. Like, for example, what is the date? Who am I? And look at the history, look at the manual for some command, right? Create an empty file, edit the file, right? View the file. It's open editor, but in read-only mode. Diff of 2 files. again, view the file at two different commands. Top command shows what's happening on your computer. htop is a better version of the same. ps shows you the processes. Like this is the BSD, like Berkeley distribution options for ps command to show everything which is running on the computer. This is the same, but more like Solaris flavor, but the result will be the same. cd, of course, is change the directory, go to the previous directory, go to tilde means home. So some directory which is in your home directory, right? pwd, print working directory, ls, and so on. And some other commands, echo, date, set, env. I usually on interviews, I ask people what's the difference between set and env. So set shows you commands which are in current session, whereas env shows you environmental variables. Environmental variables are the ones which are passed to children, to child processes. So in order, if you just want to set a variable, you say, whatever, my variable equals something. But if you want it to become environmental variable, you have to export it. So you say export my variable equals something, and then it will be passed to child processes. So this is the export. And yeah, execution a script versus sourcing a script. Again, important distinction. When you executing the script, it runs in a child process and then returns it didn't change anything in your current environment. Whereas source file means it will execute it and whatever results are will remain in your current environment. Sourcing used usually to set your environment at the beginning of the session, and it's used so often that instead of source you can just type dot. So dot space dot bashrc will source this dot bashrc file, execute all the commands, all the settings of environment, and they will appear in your session. Okay, different files may be used in different situations to set up your environment or your aliases, whether it's your login session or you're running something from cron tab. I usually put everything in .bashrc because I always confuse the difference between different dot files and which one runs when. Some other commands. I'm afraid it's becoming too technical, so maybe I'll just skip. Yeah, grep command, of course, one of the commands, original commands written again by Ken Thompson, which is simply filter. So you get some files, that means you list their content. So this is text, and then it piped into grep command with some pattern, and the result will be only the lines from here which correspond to this pattern. Very common. And then you can pipe it to another grep command. In this case, it says -v, meaning exclude. So out of lines which are coming from here, don't include files with this other pattern 2, let's say. This is an example of find command, standard Unix command. Find from this directory with the name, and you can like use star or whatever, provide some template for the name, and then print, and then you can do exarchs grep something. Like exarchs does the following: it takes whatever goes through the pipe and puts it on the end of the command. So it basically says grep for something in whatever output comes in here. Okay. More commands: copy, move, remove, tar. It's a tape archive. So you take some files or directories and you put them in a tar file, and then you can zip them, not zip, gzip. It's a compressor. So the options here: Z means compress, C means create, V means verbose, show things you're doing, F means file. So here we create this gz file from these files and directories. Instead of create, we use T, that means table of contents. It will just show what's inside this file. And if we do X, that means extract. It will extract everything from this file in current directory. So these are very commonly used commands. Or you can use zip and unzip. So this is example of usage. SSH, FTP, telnet, curl, wget. Curl is like a terminal version of a browser, and wget is a common command to download files from some websites. Killing by process ID, killing like in an impolite way, just killing no matter what. Like, don't just ask politely the process to quit, just kill it as is. Pkill and then name of the process. Like, for example, you can say pkill Python and it will kill all running Python scripts. No hub, you put it at the beginning of the command to unlink the command from the terminal. Because usually when you start the command and then you close the terminal, it will automatically close all applications it started. But if you prepend the command with no hub, then it will not die. So usually you want to do it when you start a server or you start something and then you just leave computer and go somewhere, whatever, it will continue to run. And then ampersand at the end of the command means put it in the background. Again, it's used pretty often. So here is the example of command. So I do no hub, then I say Python, my script, whatever. I redirect output to log file. This is standard output. It's file handler number 1. And then file handler number 2, I redirect to the same as number 1. So 2 means error. So whatever we're printing out goes to the log file. Whatever, if error happens, it also goes to the same log file. And then I do ampersand, that means put it in the background. And it goes in the background, I get my prompt back, and I can do other commands. If I want to look at the jobs which are running, I can do jobs and it will show me. If I do foreground, then it will take this process from the background, put it on top, and then I can do Control-C and kill it, for example. Cron tab is used to schedule stuff. Each user get a cron tab file, and you can edit it manually. And rsync command, very important command. Use it all the time. You can use it via SSH. Like, for example, to copy files remotely from one server to another. You can use it locally just to copy, move files from one directory to another directory. It can work recursively. It can, like, depending on the options. Like, for example, I commonly use these options where R, archive mode, it's recursive if preserving the user, timestamp, and so on. V means verbose. Z compress, and H human readable. So this is very common like command. Rsync all these options. Don't copy these. Like, for example, if I only want to copy code and I don't want to copy CSV files or cache files, like I would exclude them. And then I say copy from this directory into this directory. So it will create this dir directory and put everything there. Very commonly used. So here's an example of copying Anaconda directory. There are a couple more options because there are some internal links inside Anaconda, and if you don't do these options, then it will create duplicate files. So the result will be much bigger. Anaconda directory by itself is several gigabytes, but if you don't do these options, it will be maybe like 34% bigger. So this is an example of rsync using SSH. You see rsync with these options, minus E SSH, so it goes via SSH, and it takes files from this server, like user, and then server, and then you provide a directory, and then where it goes, it goes to this directory. This is not needed, sorry. Okay. So this is the example. Okay, just a second. And next, Mac OS. Well, Mac OS is also Unix, right? So when Steve Jobs was kicked out of Apple, and he started Pixar for animation movies, and he started Next Step, which was a workstation, and it had operating system which was visual, like object oriented, but under the hood it was Unix. So it was BSD Unix, and they call it Mach kernel. And when he was invited back into Apple, one of the things he insisted is that Apple acquired Next. And the modern OS 10 operating system, Mac operating system, Unix-based, this is actually a reincarnation of Next operating system, of Next Step. But it is pretty much standard Unix, and its configuration very similar. Even more than that, you can use whole wealth of Linux utilities on Mac. So there is an installer which is called Brew or Homebrew. You can use it to install like FD, HTOP, whatever, all Linux versions, all the latest versions of core Linux utilities. You can have them on your Mac. If you go on my GitHub to this file, set up new Mac, it has detailed instructions, but as I told you, mostly it's the same thing. And the last is about running Unix, Linux on Windows. Well, if nowadays, if you go on Azure Cloud, which is Windows, you will not see Windows at all, almost completely. Everything runs on Linux. Like, for example, if you go on machine learning or some clusters or whatever, it's all Linux, Linux, Linux. Windows not even an option. But if you have a Windows desktop or laptop and you want to run some Linux on it, it's very easy to do because Microsoft comes with Linux. All you have to do is activate it. It's called Windows Subsystem for Linux. And you can read this documentation how to install, activate it. In fact, by default, it's Ubuntu, but you can change it. You can install another version of Linux. And you can run Linux natively without any delays, without using virtual machine. This is actually convenient. So this is probably a recommended way. If you still need to use Windows, but you also need to do, let's say, machine learning or whatever, you need to use Windows Subsystem for Linux. Another thing you can do, Git provides Git Bash, which is a simulation of Unix environment to run Git commands. So for simple things, you can just use Git Bash. There are many other emulation programs, but I think this is enough. And we already spent 45 minutes. So I'm ending the presentation now. And I'm stopping the recording.